In this video, we'll be looking at relations and functions. A relation is a set of ordered pairs. An example of a relation is the set that contains the ordered pair 4, 3, 4, 5, 2, 6. We can also show this relation as a mapping. 4 maps onto 3, that's this ordered pair. 4 maps onto 5, that's this second ordered pair. And then 2 maps onto 6, that's this third ordered pair. Now an example of a mapping that is not a relation would be this one. Notice that 4 maps onto 3, that's okay. 2 maps onto 5. But then we have an element in the domain that is not mapped onto anything in the range. So this is not a relation. A function is a relation in which every x value is mapped onto exactly one y value. That's the important part. That's what tells whether you have a function or not. So first of all, in order for you to have a function, it's got to be a set of ordered pairs. And then you have to make sure that every x value is mapped onto exactly one y value. This relation is not a function. Notice that 4 maps onto 3, but it also maps onto 5. So this one is not a function. This relation is a function because 4 maps onto 3 and 2 maps onto 3. Now we can write this 4 maps onto 3 and 2 maps onto 3. So this is this mapping shown as a set of ordered pairs. And this one is a function. So let's look at some relations and decide whether they are functions or not. On this one, we have a mapping of 4 onto 3 and then 3 onto 3. So yes, this is a function. This mapping shows 7 mapping onto 3. But then notice that the 5 in our domain maps onto 3 and also maps onto 4. And that's the stipulation that we have a function, is that every domain element maps onto exactly one range element. So because the 5 maps onto both the 3 and the 4, this one is not a function. All right. On this mapping, we have 4 mapping onto 5. This is okay. 6 mapping onto 7. But notice that this domain element is not mapped onto anything in the range. So this one is not a relation. And remember, you have to have a relation before you can have a function. And then this is a mapping that shows any element in the set of real numbers here in my domain. And the rule is that I take that domain element, x, and add 2 to it to get my range element. So any number that we can pick in the set of real numbers, add 2 onto that, and that'll give us our element in the range that it's mapped onto. So yes, this is a function. Now let's look at some relations shown as sets of ordered pairs. we have a 1 mapped onto 2, and nowhere else do I have a 1 in the domain, so that's okay. 2 maps onto 3, and again 2 does not appear anywhere else in my domain. 3 maps onto 4, and 4 maps onto 5. So this one is a function. On this one we have 4 mapping onto 3. Now notice we also have 4 mapping onto 3, but these are the same ordered pairs. These are the same. So our 4 is not mapping onto 2 different numbers. Usually when you write a set, you don't duplicate the elements. But this one, we just wanted to make sure that you knew that it is a function because each domain element maps onto exactly one range element. 2 maps onto 2 and 3 maps onto 3. Right. In this example, we have 1 mapping onto 2, and then we also have 1 mapping onto 3. So this one is not, and there's the reason why. Remember that your x value of 1 can only map onto a single y value. And if it maps onto more than one y value, then you don't have a function. And then our last example, we have 1 mapping onto -1, and that's the only time 1 is shown. 4 maps onto -1, -1 maps onto -1, and 3 maps onto -2. So this is a function.